Welcome back. I'm Moiz Shamuddin, Assistant Professor of Mathematics, MVSR Engineering College, Hyderabad. In this part 4, we'll talk upon chi-square test. It's the very simple and the powerful test. As earlier I mentioned that we are dealing right now only of Unit 5 and this is the syllabus. In this particular Unit 5, I'll highlight it in the next slide. Okay. This particular earlier topics we already discussed in the earlier parts, and the last concept is about chi-square test for goodness of it and the independence of attributes. We will take up one problem on each of these two topics. Chi-square test, it is basically used for so many other situations also, but in this particular session we deal with only our syllabus, that is checking the goodness of it and checking the independence of attributes. Again I repeat that these are the 5 steps involved. First we'll identify the test, we'll state null and the alternative hypothesis, we'll calculate the value of the test statistic, we'll calculate or locate the critical value from the corresponding table. Right now in this case we'll look at the chi-square tables, and then we reject or accept the null hypothesis accordingly. And this is the graph of some chi-square distribution curves. For n equal to 1, it is just this curve. Okay, this curve. This is for n is equal to 1. For n is equal to 2, it is this curve which is touching the f of x axis at 0.5, this curve. Whereas you can see after these two values of n, the other curves for n is equal to 3 and the curve for n is equal to 4, they are approaching to the normal distribution. Very rough approximation, but when n increases, then it approximates to the normal distribution. Here is the same case again, that I am taking this particular curve as the curve of distribution, in this case the chi-square. One such example I have presented here. The same idea is there about the acceptance and rejection. This is the critical value, this red dot, this blue dot may be here or here depending upon the calculation. If it is less than the critical value, we accept the null hypothesis. If it crosses this critical value, we reject the null hypothesis. Let us take up a problem, chi-square test in the case 1, where we are checking the goodness of it. This is the chi-square value we have to calculate. That is nothing but the summation of these terms. In the numerator there is a square, in the denominator there is no square, and this square is taken for the difference of the observed values and the expected values. We'll see this in a problem. Find the value of chi-square for the following data and test the goodness of it at 5% level of significance. Here these observed frequencies are given, which are from the practical point of view. These observed values are nothing but obtained from a practical. Suppose if the theory suggests that these values need to be like this, then this we deal as expected frequencies, means it is expected as per the theory and these are observed as per the practical. So observed frequencies are nothing but practical frequencies and expected frequencies are nothing but theoretical frequencies. Whether this particular theory fits properly to this particular practical, let us see now. There is a difference between 14 and 17. There is a difference between 15 and 10, but whether this difference is significant or it is negligible, let us see by checking the chi-square test values. Now first we set up the null hypothesis, neutral hypothesis, that fit is good. We don't have any problem with the fit is good, we will assume. Now chi-square value is, because there are 6 terms here, 1, 2, 3, 4, 5, 6. There are 6 different frequencies given. So we take up the summation from I is equal to 1 to 6. This particular you have to memorize. Observed value minus expected value squared, and the denominator is only expected value. Just I have substituted these values from the previous data, and the final value has come as 8.80. This 8.8 is the value of the chi-square calculated from the given data. Number of observations are 6, therefore degrees of freedom will be 1 less, and it will be 5. As I stated earlier in the previous parts that every test depends upon a distribution, similarly here chi-square test depends upon chi-square distribution, and this particular chi-square satisfies chi-square distribution with n-1 degrees of freedom. So this particular chi-square value satisfies chi-square distribution for 5 degrees of freedom. Now the tabulated value for chi-square distribution for 5 degrees of freedom at 5% level of significance is 11.07. Let me demonstrate this here. At the end I have included the tables. Now the value of chi-square, you can see here, I'll better highlight it. You can see that at 5% level of significance with 5 degrees of freedom, the value is 11.07, and this is what I used in the earlier slide in the calculation. Here at 5% level of significance it is 11.07. Calculated value is 8.80, whereas the critical value is 11.07 at 5% level of significance for 5 degrees of freedom. Now since the calculated value is 8.8, which is less than 11.07, we accept the null hypothesis as I earlier stated in that particular value. This particular thing has come as 8.8, whereas this critical value is 11.07. So because of that we accept the null hypothesis that the fit is good at 5% level of significance. Chi-square test is also used in checking whether there is a dependence or independence in the attributes. Now test of significance, this is case 2. Here in an experiment on immunization of goats, it's like vaccination of goats from anthrax, which is a disease caused by that anthrax. So following results were obtained. Derive your inference on the efficacy, that is near to effectiveness of the vaccine. Now here you have to understand, here the situation is that there are two attributes which is nothing but here inoculated with vaccine, not inoculated. So totally there are 24 goats here. You need to understand that one. This particular 24 gives that there are totally 24 goats under discussion, and this there are two categories or two attributes. One is inoculated with vaccine, one is not inoculated. So how many are inoculated with vaccine is present here. This is particular 12. So 12 are inoculated and 12 are not inoculated. But in other way, if we categorize that particular 24 goats into two attributes, that is those which died and those which did not die, then died there are 8 and survived, that is 16. That is 16 here. Now this 10, please ignore this 10 highlighted. So 8 are died, 8 have died and survived 16. This is totaling to 24 goats, whereas in other categorization 20 are vaccinated and 12 are vaccinated and 12 are not vaccinated. Now we want to know whether there is a dependency in the survival with respect to the vaccine, which is vaccination. So survival, is it related, dependent upon vaccination, we are trying to see. So this particular 4 cells are giving various possibilities. If these two attributes are there and here there are two attributes, then 2 into 2 there will be 4 cells. Suppose if it is divided into 3 attributes here and it is divided into 4 attributes here, then 4 into 3, 12 cells will come here as a matrix form or tabular form. It is a two-dimensional table. Now comes the main point, that is this 2 indicates that that goats were vaccinated but still died, and this 10 indicates that these 10 goats were vaccinated and they have survived. This 6 indicates that it is not vaccinated but still died, and the last one is understood as not inoculated but still survived. Now these particular 4 cells are treated as the experimental values, or which are nothing but practical values. So these are observed frequencies. We need to find their expected frequencies. So we will work out on this particular two-dimensional 2 by 2 table. Expected frequencies are calculated as follows. Means we are ready with the observed frequencies. We are now calculating the theoretical frequencies, or which are expected frequencies. To prepare that particular expected frequencies, for each and every cell we will calculate the expected frequency. So this 2 is observed frequency. We now calculate expected frequency of these 2 just by multiplying the column total here with the row total and then dividing with the total number of items. So to find the expected frequency of these 2, I will multiply this 8. This is the procedure, having a lot of background behind it that you can see in S.C. Gupta or various other books. So this particular 8 is multiplied with 12 and we divide with 24. So for any cell, the expected value is obtained by multiplying the column total with the row total and then dividing with the total number of elements. You can see now that I am calculating the expected value of 2 as 8 into 12 by 24. That is, for this expected value of 2, it is 8 into 12 by 24. Similarly, expected value of 10 will be 16 into 12 divided by 24. All expected values have been calculated. Now I have summarized as observed frequencies are this one, which are given in the table, and we have calculated the expected frequencies. Now you can see very easily that for every cell here there is an observed value and there is expected value. Exactly, we use the chi-square test in the same like earlier case. Observed value minus expected value squared. In the denominator only expected value is used. So adding 4 by 4 cells, for each cell there is a corresponding term here. Adding all of them, we have chi-square equal to 3. Here the degrees of freedom to be remembered, that if we have m categories in this way, as I mentioned just now, this is, let us say, m categories are there and here n categories are there. As some time back I said that suppose there are 3 categories here and 4 categories here, then 4 into 3, 12 cells will come. At that time we have to look at the number of degrees of freedom as 3 minus 1 into 4 minus 1, that is m minus 1 into n minus 1. Here is m, here m is 2 and n is 2, so 2 minus 1 into 2 minus 1, it will be 1 only. So we have to check the chi-square value at 1 degree of freedom at 5% level of significance, and the tabular value is 3.84 and the calculated value is 3. So calculated value is less than tabulated value. Therefore we accept the null hypothesis that the attributes are independent. Here the null hypothesis we assume as there is no dependency in these two things. So there is that attributes are independent, means the vaccination and the survival are independent. Therefore there is no efficacy of the vaccination, means there is no effective result of the vaccination. So interested students can see that that particular chi-square distribution has this probability density function as f of x equal to 1 by so on this one. And I hope you'll do or you'll solve many more numerical problems related to these 3 tests. And let us end up with this particular small session on chi-square distribution, which is giving us the chi-square test to check that 2 topics which are there in our syllabus, that is goodness of fit and independence of attributes. Thank you.